Okay, to understand the problem, I'm going to put this ellipse in standard form just to get, uh, a very, very small rough sketch of what the question is asking. Of course, the picture isn't entirely necessary, but it does help me, in the step that is understand the problem. So I put the ellipse in standard form. I draw the point 1, 0, and I kind of like eyeball 2 points that I think are farthest away from that point 1, 0. Okay, so now I'm going to go ahead and write down that I know if these mystery points lie on the ellipse, then it must be that 4x squared plus y squared equals 4 because they satisfy the equation. And now I'm going to write down what I'm trying to maximize. I'm trying to maximize the distance from these mystery points to the point 1, 0. So I'm setting up the distance between x, y to 1, 0. And, an important observation is that this distance expression is maximized exactly when its square is maximized. So it's gonna save me on a little bit of the math later. Anyway, right now I'm just substituting in 4 minus x squared for y squared, so that my distance is a one variable function. And now I'm expressing the square of that expression, which will be a little bit easier to maximize than the distance itself. It doesn't matter if you look at distance squared or distance, you're going to get the same critical numbers and the same answer in the end. Okay, so I've taken the derivative of this distance squared function, and I see that I get one and only one critical number of this thing. I'm going to compare that critical number against the two endpoints of the domain of the distance function. I understand that the limits of the x value of a potential point on this ellipse are -1 and 1, so I can employ the closed interval method to find the maximum. All right, so I plug in the endpoints of the function, endpoints of the domain into the function, and I get 0 when the x value is 1. That makes sense. And then I get 4 when x is -1. And now I'm going to go ahead and plug in the one and only critical number that I found, which is -1/3. I just need to get this reduced to the point where I can see if it's bigger than 4. I'm expecting it to be bigger than 4 because I don't think that the point -1, 0 is farthest from 1, 0 on the ellipse. So I'm just going to do as much with these fractions as I can, and I get 16/3, which definitely is bigger. So I've discovered that the distance squared, and hence the distance, is maximized when the x value is -1/3. Of course, now I look back at the original question, which asked for the points on the ellipse. So not just the x value, but the 2 points. And this problem is has some symmetry in it, so I do expect 2 points, one with a positive y value, one with a negative y value. So I go back to the ellipse, I plug in my x equals -1/3, and I solve for y. Since I have a y squared, of course, I can get two solutions, whether y is negative or positive, and that will give me the answer to the question. So it seems that the 2 points then are -1/3, and then the positive and negative square root of 32/9, which I'll just reduce a little bit here, pulling a 16 out of the 32, and we're done.